Okay, so on our data, what we're going to do on our calculators, on our Inspires, pull the software up. All right, so what I need y'all to do is press the home key. Press home. You need to change, yeah, go up there and get you one with the right faceplate. All right, press the home key. Arrow over to where it looks like a spreadsheet. Arrow over to where it looks like it's a spreadsheet and press enter, and it looks exactly like Excel, right? So you can do Excel spreadsheets on this. Well, anytime that you want to look at data, whether you're doing mean, median, mode, whatever, or if you in this case want to do a scatter plot, this is where you put your data. Now you have to go to the top and give your data titles. It can be any name, but it has to be at least 2 letters. So our first one, isn't our X is it the diameter or the height? Diameter. So let's just call it DIA for diameter. You have to use the little green buttons for right now. Now some of y'all have the new faceplates and you use the stuff at the bottom. Okay, I'm getting the new faceplates for mine. Then just do down and I'll call that column diameter. And then we'll go to the top of the B column and call it height. We'll just do H. We can call it whatever, HT, or you can spell out the word height, call it HT or something, just something so you know it's the height. Okay, now go and enter your numbers. Okay, so that's the easy part. So enter your numbers. For me, it's easier to do the X first and then do the Y. So I'm going to do 2 down, 3 down, 4 down, 5 down, 6 down, 7 down, and 8 down. And then you arrow over and do the height numbers. 8, 10, 16, 17, 22, 20, and then 29. Oops, skip count. Okay. All right. Okay, does everybody have the numbers typed in? Okay. Now, let's suppose all you wanted to do, which is, let's say all you wanted to do is just get the equation. All I want to do is get the line of best fit. I want to know the best line. Okay, you're going to do it totally on this screen right here. So what you do is arrow over to the right beside the 8 in a blank cell. The reason you want to arrow over there is because that's where it's going to put the answer. Okay, now follow me carefully, and you may want to jot this down so you remember the keystrokes. Now, y'all that had me before, this should come back to you because you did this 2 years ago. Okay, so you do menu. Okay, if you get lost, if you look up here, when I push a button on my computer, it always makes it red if you can't find where I'm at. Okay, so, yeah. All right, so I want to do some statistics, right? When we're doing lines of best fits, we're doing statistics. So you're going to go to number 4. Okay, somebody said calculations. So we're going to do 1. Okay. Now you have all of these regressions. All right. Now, what's going to end up happening, when we start doing mean, median, mode, and then add to that, we'll do 1 variable statistics. That's where you get your mean and your median and standard deviation and stuff. Okay. We're going to do a linear regression. Now, the reason there's 2 of them is because in algebra, you want mx plus b. In college level statistics, you want a plus bx. Technically, it doesn't matter, but I want you to use mx plus b. So we're going to do number 3. Okay, now you get a menu. X list. You've got to tell the calculator what your X variable is. All you do is arrow down, and you tell it, is X diameter or height? So you go down and highlight it, and press enter. Now what else do I need to tell it? Okay, so the way you get back and forth is just like on a computer. When you go from field to field in a computer, you press the tab key. Tab is over there under escape. So tab, and now go down, and we're going to call our Y height. Okay. And then the rest of the stuff you just leave alone. Okay. And if you press enter right now, it's going to spit out the answer. Okay. So see, my answer wasn't good at all because it says the best answer has a slope of what? 3.178. Okay. Right at this point, you don't know enough math yet to understand statistically how they're calculating what's, quote, best. For right now, you're just learning this is the best.
So M is best.
Huh? That's just the answer. Okay? All right. Now, so here's what we're going to write down. Okay, no big deal here. So your line of best fit using y equals mx plus b. Here's m. So our equation is now 3.17857x plus, then you go down and there's your b. Okay? So this is the best line. Y equals mx plus b. Now, my rule of thumb, if you're going to round 3 decimal places, you have to always do at least 3 decimal places if you're doing decimals. So if you want to round it some, you would say 3.179x, and then your b is 1.536. That is the best line that goes through the points. Okay? Now, what the computer can do that you cannot is it doesn't necessarily pick 2 points that are actually plotted. It can statistically figure out the exact way the line should go, and it may go through 2 points, it may not go through 2 points that we plotted, but it can statistically figure out which points should it go through so that the points are the closest possible to the line. It has a way that it can figure out the way where the line should be so that the points are the closest to the line. That's the best way of doing it. Now, you'll notice, though, your calculator gives you something else. It gives you something called an R value. And the R value here is 0.959. That is important, okay? That is called the Pearson something, I'll have to look it up, but it's your coefficient of regression. Now, here's the thing that you need to know about your R values and the 2 things it tells you. First, since it is positive, this tells me that I have a positive slope. So that means this thing is going to increase. The R value tells you if it's positive slope or not. If it were negative, the line's going to have a negative slope. It also tells you that you have a positive correlation. But here is the final thing that it tells you. If it's between 0.9 and a 1, that is an excellent, excellent fit to the data. If it's between negative 0.9 and negative 1, it's an excellent fit to the data. Now what can happen, guys, when you get into more statistics, and we'll be looking at this more, but you can have points that are kind of sort of linear, and you can get a line of best fit, but the line isn't so good. It might be just okay, so-so, but it is usable. Now what would this line actually look like? Okay, well we can do that on our calculators too. So back on your Inspires, let's actually look at what the line of best fit is. So press home, and I want you to go over to the 5th icon that looks like a graph, and then press enter. Now right now you just have a bunch of random dots. Now here's what we can do here. Press the tab key, and what did you make your x-axis when y'all did your scatter plot? So press enter and pick diameter. Now press tab again. What'd you let your y be? Height. Now there's your scatter plot. Okay. Now that's your scatter plot right there. Now, if you wanted to get your line of best fit, you can do it on this screen as well. The only thing, it won't give you the R value. So just take a guess. How do you think I'll get the line of best fit? What did we do just a minute ago? Menu. Where do you think? Analyze. Now where? Regression, number 6. And which one? Show linear, mx plus b. Now there is the actual line of best fit. And you'll notice it looks like it goes through one of the points, but not necessarily a second one. And statistically speaking, what the calculator and what statistics can do is it can figure out what line can be drawn so that all of these points are the closest distance possible to that line. Yeah. Okay, so when does that happen? All right. Now, first of all, how do you get back to the spreadsheet? Well, you do Control left. And Molly, if that happens, that means you have an extra number in one of your columns. In your diameter or height column, you've got an extra number or a missing number somewhere. So you look through there and see if you can find it. Okay, I'll have to look at that in just a second. We're going to do another problem, so we'll have to, I'll look at it in just a second. Yeah.
Can we not do all this in our head or something?
No, you cannot. You're smarter than me if you can do this in your head. I can't do this. All right. Now, what do you do with this then? What is the point of it? Well, the point of it is I now have this regression equation. This is what you need to write down on the handout somewhere. So you now have this regression equation. Now, what we've just done here, this is just, the only thing that's really should be new is the R value. When I taught Algebra 1 the last 2 years, this is a part of the curriculum that any Algebra 1 student should do, getting these regression equations. So this part shouldn't be new. All that should be new at this point is the R value. Now, it may be new for you to do it on an Inspire, but as far as doing this, this is something that shouldn't really be new. Here's the new part. How do we use this? Well, what you can do is use this to make a prediction, and that's where E comes in. What if I have a diameter of 14 inches? I have all of this data, and I want to predict, well, what will the height of the tree be? Okay, so here's where you got to think for a second. Is X our diameter or is Y our diameter?
X.
Okay, so really, this equation would have made more sense if I let X just be the variable D, wouldn't it? And what was your Y variable in this problem? Height. It would have made more sense to call that H. And so what you simply do is substitute 14 into the diameter, and then we can predict what the height is. So we just type that and get the answer. Now the way you do that on the Inspire is if you press home, pick the first icon, and then you can just use it as a regular calculator. So do home. There's a parentheses button. Right here. So what did y'all get?
46.
Okay. Now what you did there, and it mentions this at the top, at the bottom of the page, that's called an extrapolation. The reason it's extrapolation is because 12 or 14 would be way over here outside of where our points are. So if you extrapolate, you go beyond where the points are plotted to get your prediction. Now, an interpolation would be if I picked a number between 2 and 8 and did the same thing. Okay? All right, this is the whole point of doing lines of best fit. Okay, so now turn the page, and now we're going to pretend this was a homework problem tonight. And we have this data. Now, the nice thing about these calculator problems is you don't have to do a scatter plot by hand. You don't have to pick 2 points and draw a line and do a line of best fit to get a best fit line that way. You get to pretty much do all of this on a calculator. So let's go through one more problem and make sure that we can see how to do it. Okay, so I'm going to do home. And I'm going to go over to a spreadsheet. Now let's read what my problem on the back page says. It says a real estate agent's trying to determine the relationship between the distance a 3-bedroom house is from New York and its average selling price. The data is there. We did home. And go over to the 4th icon and press enter. All right, so up at the top of the page, I'm going to call this miles, or MI. And then on top of the second column, I'm going to call it PRI, or for price. Are you not going to do this? Are you not going to do this? Thank you. All right, let's type in our numbers now. So we got 10, 35, 50, 65, 75, and then 120. And then we'll do our numbers for the price. 755,000, 650,000, 580,000, 505,000, 475,000, 285,000. Okay. So you're doing home, go over to the spreadsheet icon, press enter. You always put a title on the top rows. Has to be at least 2 letters, but you can make it longer if you want. Type your numbers in. Now, basically what's going to happen then, when you do this on the homework, they're going to ask you 3 or 4 questions. Question 1 is, what's the line of best fit? So we can do that right here. Arrow over to the top of the data to make sure it's where you can see it. And how did I get that best fit line? Menu, statistics, stat calculations. So I did menu, statistics, stat calculations, and then which one? Number 3. Okay, so I get to this little chart right here. Now you're going to have to tell it what is your X and what is your Y. So arrow down. Now it still has diameter and height in there, but this time we're doing miles. And then how do I go down? Tab. And then pick price. And just do enter. And there's your answer. So my model is y equals negative 4,291.1. But you know, I like 3 decimal places, right? So to actually get all the decimals, what you have to do is if you arrow down, it'll show it. It's itty bitty, but it'll show it. And if you go down to your B, it's itty bitty, but it will show it. Okay, so it's y equals negative 4291.1 something 102 x plus, and my B is covered up. What is it? 795 6.865. Okay, so there's our line of best fit. Okay, remember what I was saying, you got to arrow down and highlight that number. Now, if it's not giving you decimal places, Josh, somebody's messed with the setup on it, and I can change it the way it's rounding. Okay, now, one of the other things it's going to ask you for is the R value. Okay, now look at the R value on this problem. We'll have to arrow down. The R value is negative this time. What does that tell you about your line of best fit? It's decreasing. So if R is negative 0.9992, that means it is decreasing, right? All right. Now, here there's a variety of questions then that you could be asked then to interpret this. Now on the handout they've got A through F, but just take a look at B for instance. It says Woodstock is 95 miles from New York City. Use this model to estimate how much it would cost. Okay, so now think for a second on B part. 95 miles, is that your X or is that your Y? So what would you do with that 95? Plug it in. Okay, we're not gonna have time to do that, but what you would do is plug 95 into the X and then figure out that answer. Okay, that's how you would do B. You'd plug 95 into the equation where you got mx plus b. Huh? 7955, right. On mine, I like I said, when I write and go back and forth, you have trouble seeing it. Okay, is this making sense? I can't see my number. You have it. I just can't see my number. So, okay. Now, last thing, and then we'll spend a little bit more time on this later in the week. This, your homework's right here. Yes. No. You haven't gotten the homework yet.
Is this like our homework?
Yes. All right. So, now don't put your stuff. Now, if you look at the homework you just got, it's got 3 problems, right? The back side is just how you do it on an 84 if you want to do this on an 84 instead. Now, there's one other thing about the homework that I need to talk about. If the bell rings, you just need to stay put. It'll take me just 30 seconds. That problem had a slope, right? What was the slope on the problem we just did? Can somebody tell me what it was? Okay. What was it again? 9.1 or something? 0.102. Okay. That slope has a unit. Remember how I told you when you did change in y over change of x? Give me 30 seconds. You know how it's got change of y, change of x? That has a unit. So what was the unit for y? Isn't it dollars?
Yes.
And then what's the unit for x? Miles. So on the homework they're going to ask you, well, what does that mean? Okay, so what happens is if it's negative $4,200 per mile, the negative means it's decreasing, and it's decreasing at a rate of this many dollars per mile. And that's all you have to do for